packaged and processed and ready to leave the recycling center and go out into the world to be reused, the materials that were made in those stars that were then finally cooked and blown out into the universe by the supernova process, those will be reused as well. They may be used in other stars or perhaps other planets. The materials that we're made of here on Earth, the materials even in our bodies, those heavy elements were made in supernovae.
While supernovas are massive explosions themselves, they can also trigger secondary blasts with even more concentrated energy. Number 2, long gamma-ray bursts. The long gamma-ray burst comes out of the most powerful supernova explosions. They're as strong as the short gamma-ray bursts, but since they last much longer, anywhere from 2 seconds to nearly half an hour, they blast out much more energy overall.
The long gamma-ray bursts are completely different beasts compared to the short gamma-ray bursts. They're immensely more powerful, maybe up to around 10,000 times more powerful than the short duration bursts.
These concentrated jets of energy only come from supernova explosions involving stars 30 or more times the mass of our Sun. And just like the short gamma-ray bursts, they're evidence of the birth of a black hole.
Long gamma-ray bursts are, in some sense, a variety of hyperenergetic supernova. The iron core collapses as before to a neutron star, but too much material falls down on it and it can't stay a neutron star. The temperature rises to 10 billion degrees. The luminosity in 1 cubic inch of this is as big as the sun. And this power can't flow out on the equator. It gets focused like in a shotgun blast out the rotational axis of the star.
So how much energy do the most powerful long gamma-ray bursts release compared to our Sun? The answer is shocking. We're at number 2 in our countdown of the biggest blasts in the universe, long gamma-ray bursts. They're the most powerful concentrated beams of energy in the universe. They release many times more energy in a matter of seconds or minutes than our Sun will produce in its entire 10 billion year lifespan. The key to their devastating power is focusing that energy in a narrow area. A firearms expert illustrates the point with 2 different shotguns. First, a shorter gun, where the shot spreads out quickly after leaving the barrel, unlike a gamma-ray burst.
As you can see, there's some damage to the melon, but not that much because the shot was spread out and only some of it hit the target.
Now our firearms expert is switching to a longer barrel that keeps the shot concentrated in a tighter pattern as it goes downrange. The same effect as a gamma-ray burst.
Concentrating the shot can be devastating. It's a good thing for us that most gamma-ray bursts are millions or billions of light years away from Earth and are pointed in the other direction.
It's believed that these concentrated jets shoot out when massive stars collapse into black holes. And in 2008, scientists detected one of the strongest gamma-ray bursts on record, known as GRB 080916C. It lasted an incredible 23 minutes.
This GRB was one of the most exciting blasts ever seen because the total power inferred from the observed brightness and the distance of the blast exceeded that of any other known GRB up to that time. Moreover, we can tell that energetic particles were blasted out along 2 jets at 99.9999% of the speed of light. GRBs are so powerful along the beam of particles and radiation that even ones that are thousands of light years away, but pointing at us, could destroy much of the life on Earth.
But if long gamma-ray bursts are the most powerful explosions in the universe, then how could they be number 2 on our list? Because the top spot goes to something that didn't happen within the universe, but happened when the universe itself was formed. Number 1, the Big Bang. This mother of all blasts is technically an expansion and not an explosion, since it was not a blast within a defined area.
It wasn't an explosion that happened somewhere in space. It's all of space. It's the actual fabric of space-time itself coming into existence. So in the concept of a biggest blast, it's as big as it gets. It was the whole universe blasting into existence.
And the speed and temperatures of the Big Bang dwarf anything that happened inside the universe once it was formed.
Those temperatures are beyond anything we can imagine. There are trillions of degrees if you measured it in usual units. So compared to any explosion, say here on Earth or a star or what have you, this is well beyond that.
Researchers believe that theoretically, they can go back so close to the moment the Big Bang happened that a fraction of a second doesn't come anywhere close to doing the timescale justice.
The bang of the Big Bang is a time in the early universe known as inflation. The size of the universe went whoosh. It just expanded so quickly, doubled in size many times over a very, very short interval of time. This incredible inflationary exponential state of expansion lasted only a tiny fraction of a second. A millionth of 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 a second.
During this early expansion, it seemed as if things were moving faster than Einstein's universal speed limit, the speed of light.
In fact, it expanded so quickly that it was faster than the speed of light. That's okay. That doesn't violate Einstein's theory of relativity. Space itself can expand faster than the speed of light. No particle can travel through space faster than the speed of light, but space itself can and does expand faster than the speed of light.
And the Big Bang is the largest reminder of all that the biggest blasts in the universe, these sudden releases of energy, do much more than destroy.
The creation of our universe, the creation of the sunshine that comes out of stars, and the creation of our own moon all came from this tremendous liberation of energy all at once. So there's a very intimate link between matter manifested in one way and then being destroyed and then re-emerging in a new way. And, you know, here on Earth, it re-emerged as us.
And as the universe evolves, its biggest blasts will continue to be both the destroyer of worlds and the creators of new possibilities.